Okay, so I've basically taken all the tubes out of this rack, taken the lids off, placed them in this container, and put all the tubes in this rack upside down. The advantage of that is that they're draining out any schmutz that's in there and any RO water. Also, you can see some of the tubes have been sitting for way too long, and there's some algae on the bottom. So what I'm going to do, I have a squirt bottle of methanol here, which has evaporated. So I'm going to run away from the camera. So isopropyl alcohol works just as well, and it's a lot cheaper. I buy it at Costco because there's no shipping charges. And so now I just sprayed a little isopropyl alcohol on the bottom. I'm going to resuspend that booger and get rid of it if I can. This one's a pretty tough one, so maybe this one will have to sit. So that should be a lesson, basically. Try to, when you're getting rid of cultures, emptying them right away is better. Rinsing them out if you can. So this tube has something that's sticking in there quite well. So I'm going to let that sit there. Okay, so this is RO water, which is reverse osmosis water. There's 3 levels of water in the lab. There's tap water, right, which has a resistance of about 2 megaohm, which is a measure of how electricity goes through the water. RO water has a resistance of about 16 megaohm, meaning that there's fewer impurities, so the resistance for for the conductance of electricity is lower. And then over here, if you want to walk over here, we have milliQ, which has a resistance of 18.2 megaohm. This is our intermediate rinsing station, which basically is where materials visit first before going into the clean lab for final rinse. And we'll be working on this today. Okay, so now we have the rack of tubes and the bottle of caps. I'm going to give the bottle of caps a quick rinse. Again, I'm going to let all that rinseate go into the bleach because of genetically modified diatoms. And now we're ready for the micro clean, the micro cleaner soak. Now, in order to do the micro cleaner soak, we want to submerge these tubes in a bath of micro cleaner. The easiest way to do that is not submersing them one at a time, but submersing them en masse. And so we have this simple method here where we have 2 racks. Now they're all facing up the right way. Now let's go over to the micro bath. So we have these pieces of you can buy it in Home Depot. It goes on fluorescent light fixtures. It's polystyrene, kind of a brittle plastic, but it's really useful for helping us rinse things rapidly. And so this is a 2% micro cleaner bath. Okay, you can see we have a couple different racks of tubes in here already. And so these are ready to get removed from microcleaner, go into acid. This one is about to go into microcleaner. If I don't put this rack on here and I try to press this down, all these tubes will float out and it'll be a big mess. So with this rack depressing, there's some other interloping plasticware in this bath. So now the entire tube has been rinsed. And now we have a tube here. We could pretend that this is soaked for a couple days. And we have basically a rack of tubes that has soaked, and we're going to remove that for the next step. Okay, so we're gonna remove this for tap water rinsing, but first I'm gonna place today's newly cleaning batch of caps in this microcleaner bath. I'm gonna do the best I can to get rid of air bubbles that are inside, that are underneath the caps, so I'm going to kind of gently invert it and try to get most of the air out so all the surfaces are contacted with micro. And then I'm going to place it on the left next to the new rack. Now ideally there should be a labeling system where you know when each individual rack of tubes went in, because you want to give it a couple days. The micro cleaner is a highly soapy, slightly alkaline pH solution that digests any organics that are on the wall of the tubes. Okay, pause.